Hey, pre-calc. So we're going to do now today involving a fabulous wheel of fish. Calculate the mean absolute deviation, variance, and standard deviation for the number of fish you'd win for one spin. Hit pause on the video until you got your answer, and then you go ahead and hit play again. All right, well, the mean is 4, mean absolute deviation is 3, the variance 12.5, and the standard deviation is 3.54. How many decimal places you wanted? I went with 2. Well, as it turns out, there's actually more due now. What if we wanted to combine the mean absolute deviation, variance, and standard deviation for spinning that wheel of fish not once, not twice, not even 3 times, but for 4 times? Well, you would be able to add the means. 4 plus 4 plus 4 plus 4 gives you 16. The mean absolute deviation, well, we can't actually do that right now. So pretend like I didn't actually ask. It would take a lot of work to calculate that. And nobody cares about the mean absolute deviation anyway. Okay, that's not true. We don't need the mean absolute deviation right now. Changing the directions. The variance, we can add all of those. 12 plus 12 plus 12 plus 12. It's 48. And then the standard deviation, we'll have to do the square root of 48. We don't get to use any of those standard deviations to add them together. And calculator, square root of 48, 6.9. And of course, you could use more decimal places if you want, but 6.9. All right, well, today we're going to look again at variance and standard deviation, also mean, and not so much mean absolute deviation, but we're looking at our summary statistics today, focusing on how to calculate them if you have a repeated event, the same event repeated over and over and over again. Let's say R times, so R repeats of the same event. All right, well, let's back up 1 second. So we actually just looked at a repeat of the same event. We had the same wheel of fish spun 4 times, and we could just add the mean, 4 plus 4 plus 4 plus 4, but really isn't that the same thing as just taking the mean and multiplying it by the number of repetitions? The mean was 4, and there were 4 repetitions, and 4 times 4 is 16. Didn't we actually just do the kind of the same process here with the variance? We took 12, we added it 4 times. That's the same as multiplication. It's just 12 was the variance multiplied by 4 repetitions to get 48. And then the standard deviation, well, it's always the square root of the variance. So we could say this. To calculate the mean, the variance, the standard deviation for a repeated event, we're going to take our mean and variance for one iteration of the event, just doing it one time, and then multiply by the number of repetitions. So for the same event repeated over and over and over again, R times, the mean for the R repetitions is just the mean of once times the number of repetitions. The variance multiplied by the number of repetitions. For standard deviation, always, 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 no matter what, it's always the square root of the variance. Or in this particular case, there's actually another option. We can take the original standard deviation, and here's a shortcut, multiply it by the square root of the number of repetitions. And this really is only helpful if the number of repetitions is a perfect square. You can always do it, but it's not really any faster than just taking the square root of the variance, unless you got a special situation where, oh, it's a square number for the number of repetitions. Okay, so I combined the shortcuts we found yesterday along with the ones for today, so we can put them all into one table. Size of the sample space, if you have n outcomes and you're doing R repetitions, is just number of outcomes to the power of how many repetitions. We've seen that before. That's like the very first thing we ever learned in statistics. The mean, take the original mean, multiply by the number of repetitions. The mean absolute deviation, if you really need it, you're going to have to recalculate with a big, big, big calculation table. You probably will never need it. Variance, multiply that by the number of repetitions. And for standard deviation, either take the square root of that new variance, or you can multiply the original standard deviation times the square root of how many repetitions you are doing. Here's an example. Let's take that wheel of fish that we just saw from our do now. We've got the original mean, variance, and standard deviation. If we're going to do one of these questions at a time, find the mean, variance, and standard deviation for 10 spins. Well, if we're doing 10 repetitions, we're just going to multiply the mean times 10. So that's 40. Take the variance and multiply by 10. And then we're going to do the square root of 125 to get our standard deviation, which my calculator tells me is 11.18. Done. What if we wanted to find or needed to find the mean, variance, standard deviation for 100 spins? Well, we just go back to those green numbers, and this time we'll multiply by 100 instead. So 4 times 100 is 400. 12.5 times 100 is, oh my gosh, get the numbers in the right order, 1,250. And then for the standard deviation, do the square root of 1,250, which is 35.4. Or, check this out, 100 repetitions, square root of 100 is 10. You can multiply the original standard deviation by 10, and it will also give you that exact same number of 35.4, which sometimes is handy. A little bit of mental math goes a long way. Sometimes it's not so handy. Let's, as one last example, find the mean, variance, and standard deviation for the sum of rolling 4 dice. So I've got this table showing a bunch of work we did earlier, expected value, variance, standard deviation for spinner A, spinner B, spinner C, but all we need for this problem is just that die. So roll this guy 4 times. So we already calculated the mean, the variance, and standard deviation for one roll of a die, and now I need to do this for 4 dice. Multiply by 4. 3.5 times 4 is 14. 2.9 times 4, 11.6. And then I can either do the square root of 11.6 to get our standard deviation. Just 3.4, if I can write it. Or, check this out, 4 is the number of repetitions. The square root of 4 is 2. I can multiply the original standard deviation by 2. 1.7 times 2 is also 3.4.